Hello, this is Mr. White, and this video is an introduction to piecewise functions, which is something that you will see from time to time in pre-calculus. You'll see it even more often in calculus. You see the note there? Put the calculator down. We're not going to use it in this lesson. However, I would ask that you grab your textbook and open it to the page where the 12 basic functions are displayed. If we're still using the 6th edition as you're watching this video, the 6th edition of our textbook, that would be pages 102 and 103. Alright, so in this chapter, in this section, you're going to be asked to do things like construct a piecewise function for the function whose graph is shown here. I understand if you don't know exactly what that means, I'll explain. Let me start by at least saying I hope you even if you don't understand those directions, I hope you see some familiar shapes there in that picture. I hope you see that as a combination of our basic functions, and that you're able to divide that into several pieces based on your familiarity with those shapes, which I believe should have been introduced to you by now in class, those basic functions. So there I've divided it into the 3 pieces. I'll go ahead and note that the book typically in its examples and in its exercises will have you dealing with 2 piecewise functions, but I thought for the sake of this video, let me have you get comfortable with 3 piecewise functions, and if you can do that, the ones in the book should be easier by comparison. Alright, let's focus on one piece at a time. So let's focus on that first piece of the piecewise function, which hopefully you can narrow down to either the sine function or the cosine function. If you look really closely, you'll notice that only one of those two, the sine or the cosine function, goes through the origin like this graph does. So hopefully you say, oh, based on that observation, this is the sine function. So let's go ahead and write sine of x. And what we also need to do is write the interval over which we are using this function. We are not going over its entire domain from negative infinity to infinity. You hopefully recognize that as the interval from negative infinity to 0. Now, whether we put parentheses for that 0 or whether we decide to put a bracket for the 0, I'm going to gloss over that for this example. So I'm just going to put the black bracket without explaining much further. I'll get into it a little more in the next example. Now, here's one more thing that I'm going to do to frustrate you. You're probably just getting comfortable with this interval notation, and I'm going to go ahead and switch it on you again. We're going to go back to inequality notation. Why do the math people keep doing this? I don't know. I didn't make this up, ladies and gentlemen, but hopefully you're comfortable with both. So instead of having it in this interval notation, I'm going to put a comma after the sign, and I'm going to put x is less than or equal to 0 as indicated over here. And even though the book doesn't do this, and I normally wouldn't do it, just for emphasis, and it doesn't hurt to do it, I'm going to put the rest of that inequality there. So again, you should very clearly by now know the connection between this inequality notation and this interval notation. I'm going to go ahead and erase the interval notation because that's just what's typically done for these. We typically use the inequality notation for piecewise. So let's go on to the next piece. There is our next piece. I'll use red for this one, and if you look in your textbook, I hope you identify that as the square root function. So I will write a square root under here, square root of x. And once again, I'll write the interval as 0. I'm going to go straight to inequality notation this time. And again, I'm going to ignore how I'm choosing to do the less than equal to versus the less than. I will address that later, I promise. Okay, let's look at our last piece. This one will throw you for a little bit of a curveball. I think a lot of you are ready to handle it pretty well. You should identify that as the absolute value function, but it's not the basic absolute value function. Notice in your textbook that the basic absolute value function goes through the origin, and this one has been moved to the right 6 units. So it's not the basic one, it's been moved. that we will formally address how do we move or transform functions at a later time. For right now, I'm giving you a little bit of a sneak peek at that. I'm going to go ahead and write what its equation is, and I think you'll be able to connect the dots there and get a sense of how this will look in the future. So this equation is absolute value x minus 6, and we are working on the interval from 4 to infinity, right? So in inequality notation, it would look like this. I'll repeat once again that you really don't have to write either this here or this here. You could completely leave that off, and I normally will, but for the sake of this one example, I just wanted to put it in there to make it look more like the interval notation you become familiar with. The last thing that we need to do is we need to name this function and really make it clear that these are not 3 separate lines, 3 separate problems. They're all one common function, and we do that with an open bracket. You're probably expecting me to say that we'll put a closed bracket over here. Well, you're wrong. No, we don't. We just use the open bracket, and we say f of x, or whatever you want to name it. I didn't tell you how you had to name this function. You could have said h of x, g of x, whatever. That, ladies and gentlemen, is our finished piecewise function. We are done. I hope that made sense, because I'm going to ask you to try one on your own here in just a moment. All right, let me go ahead and go to the next page and have you pause the video and try this one on your own. Okay, I'm assuming you've tried it on your own now. I'm going to reveal the solution. All right, there is my solution. You may see a symbol there that you're not familiar with. That middle symbol there, that's what the book calls the greatest integer function. It calls it int of x, but you'll often see it with this symbol as well. Some other computer programs also call it floor of x, such as Microsoft Excel calls this the floor function. Okay, so it goes by a variety of names or symbols. I'm going to leave it at that. Oh, and one other point I want to make. Again, I glossed over the less than versus less than equal to. Let's say you got a couple of these confused. Let's say that you put the less than or equal to here, but you made this just less than. That would be perfectly acceptable too. Likewise, if you had done less than equal to, perfectly acceptable. What you don't want to do is have less than equal to here and here. But rather than keep on expounding on that point, I think I'm going to save that one for later, for class, to really get into the details of that. But I invite you to remind me and ask me about that in class as well. Okay, one more exercise, one more part of the lesson. Okay, so before you were given a picture and asked to construct the definition, here you're given the definition and asked to draw the picture without using a calculator. All right, so again, with your textbook open to the basic functions page, let's get started. Let's first observe, let's start with that first definition, this up here, and let's observe not only the shape, but the part of the domain that we're going to use. We see this is going to be an x cubed function. For all values x less than or equal to 0, and again, if I really wanted to, I could have done that greater than negative infinity thing. All right, so we know the x cubed function. If you look at that closely in your book, we should, and plus, just by plotting points, we should be able to say that x cubed goes through 1 cubed, 2 cubed, -1, -1 cubed, -2, -2 cubed. We should be able to plot points. I sure hope you know what I'm talking about. If you don't, please come see me. And we should, oops, that's not the pen that I wanted. I wanted this pen. We should be able to sketch freehand without our calculators the x cubed function. But you're probably thinking, Mr. White, don't we need to restrict that domain? And you would be correct. I need to honor this constraint there, that x we only want the values for x less than or equal to 0. So I'm going to go ahead and erase the x values that are greater than 0 and only keep the ones that are less than or equal to 0. And to really punctuate that, to really emphasize that I'm keeping that it's less than or equal to 0, definitely put a dot there and fill it in, as opposed to, you know, sometimes we do the whole like that. Fill this dot in because this is less than or equal to 0. All right, let's go on to our next one. That is our logistic function. I'll confess that we're not going to use that a whole lot this year, but I would suggest, I hate to put other teachers on the spot, but I'd suggest you ask your biology teacher about that one. That's typically what students tell me, the class where they hear about the logistic function. Let me use green for that one. And again, looking in your textbook, one of the main features of the logistic function is that it goes through the point 0, 1/2. So I'll start by putting that y-intercept of 0, 1/2 right there. The logistic function would normally ride along the x-axis asymptotically, rise to the point 0, 1/2, and then continue getting asymptotically close to y equals 1. But you know how we do this. We only want the values between 0 and 4, so I will erase all of that except for the parts between 0 and 4. And one other thing I want to do is, again, acknowledge that this is less than x is greater than 0. Therefore, I should put an empty circle there. And x is less than or equal to 4. Therefore, I should put a point right there. Given the size of my picture, that looks like the coordinates 4, 1. It's really 4, 0.9, something, 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 but we're just drawing this freehand, so we won't obsess over such details like that. Finally, last piece of our piecewise function. You know how to graph a linear equation, right? Slope, y-intercept. If you don't be embarrassed, come talk to me, but I really do expect that you should know how to do it from here on out. So don't be embarrassed, but come see me or somebody else who knows, and make sure that you do get that down, because you're going to need to know how to graph a linear function. I'm going to say, okay, my y-intercept is 5. The slope is negative 1/2. That means I'm going downhill, so I go down 1 over 2, down 1 over 2. I'm going through this quickly because I hope that this all sounds familiar, and that you'll see points. I only want the x values that are greater than 4, so I erase that. And do I put a circle or an empty circle or a filled in circle? What do you think? I hope you're looking at that and saying, oh, x is greater than 4, so I need the empty circle. And there we have it, ladies and gentlemen. That is our graph of this piecewise defined function. I'll clear this off. Hopefully you're looking at that saying, yes, that makes sense, because I'm going to ask you to try it on your own here in just a minute. Actually, you know what? Not just a minute, just a moment. Here it is. You try that one, please. Pause the video. Ideally, you would have some graph paper in front of you. I realize not everybody has that, so you can make do with just lined paper. So pause the video, sketch it. In just a moment, I'm going to reveal the solution. All right, let me shrink this down a little bit and then bring the solution onto the screen. You should have something that looks like this. Notice in this one, unlike the example that I did, none of the 3 pieces connected with each other. Notice in this piece that it does connect here, but then it does not connect down here. So, does it connect, does it not connect? Just draw the pieces, restrict their domains, and you'll find out how they connect. One thing that you may have found a little bit challenging, maybe you thought it was a dirty trick of me to give you something that looks like this function. Well, I hope that if you needed to, you just plotted some points, plugged in some x values, started plotting points until you saw the parabola emerge. Whether you did or whether you didn't, I would ask that, again, as a preview to future content, that you look at that and examine and you wonder, what is the significance of that 1? What is the significance of that 5? What is the significance of that negative sign? And hopefully when you're looking at this parabola here, you can observe where the 1 comes into play, where the 5 comes into play. What does that negative sign do? That'll give you a big leg up when we get to this content of transformations in another section or two. All right, if any of that didn't make sense, please come see me during office hours. Thank you.